converting logarithmic functions into exponential functions. So you can see right here that we have log base b of n equal p can be rewritten as b to the p equal n. So here b is the base of both the exponential and the logarithm. It's the base of both. We have a couple conditions for b. We see that b always has to be positive but can never be equal to 1. And then in our n and our p are just real numbers. So what does this mean here? What are we doing? Like I said, the base is always going to be the same. The base of the logarithm is the same as the base of the exponential. But these are inverse processes. If you have inverse functions, recall that the domain of f is the same as the range of f inverse and vice versa. The range of f is the same as the domain of f inverse. In other words, we switch inputs and outputs. So, the input of this logarithm is n. It becomes an output of an exponential. And the output of the logarithm, p, is the input of the exponential. So b to the p equal n. You see we're switching inputs and outputs? And some people like to do this little fun arrow thing. b to the p equal n. I can do a lot of things with exponentials. I understand how the powers work. I have a little harder time with logarithms. So if I can change my logarithms into exponentials, I'm usually in a better position. So let's try some. Find m by rewriting each logarithm as an exponential. So let's first identify the base. The base here is 2. So we're going to rewrite as an exponential with base 2. And then we know that the output of the logarithm is the power, right? So if your logarithm equals some number, that's really the power of an exponential. So the power here is the 5. And it equals m. Because m was the input of the logarithm, it's going to be the output of the exponential. 2 to the 5th equal m. What's 2 to the 5th? Well, that's 2 times 2 times 2 times 2 times 2, which is 4 times 2 is 8, times 2 is 16, times 2 is 32. M is 32. Let's try another one. Log base m of 64 equals 3. Well, now we don't know what the base is. So we are going to rewrite m as the base of the exponential as well. The power of my exponential, wrong color, the power of my exponential will be 3. Remember, we jump across the equal sign. And the output of the exponential is 64 because that's the input of the logarithm. So m cubed equals 64. We solve this. If you're not sure how to do that, you just start plugging in numbers, right? 1 cubed is 1. 2 cubed, well, that's 2 times 2 times 2, that's 8. 3 cubed is 3 times 3 times 3, which is 27. Still not there. 4 cubed, well, 4 times 4 is 16. Times another 4, yes, we do get 64. So m is 4. Let's do another one. Log base 3 of 27 equals m can be rewritten as an exponential. The base is 3. Remember, we're jumping across to get in the power, and this is going to be the answer. So the power of this exponential is m. And the output is 27 because that was the input of the logarithm. So 3 to what power is 27? Well, 3 to the 1 is 3. 3 to the 2 is 3 times 3 is 9. 3 to the 3 is 9 times 3. Yep, we get 27. So m is 3. Hopefully this is starting to make sense. Let's do a few more. Log base 64 of m equal 1/2. Well, that can be rewritten as an exponential. The base is 64. And the power of my exponential is the output of the logarithm. So that's 1/2 equals m. The input of the exponential, remember, is the output of, the input of the logarithm is the output of the exponential. So 64 to the 1/2, remember that a 1/2 power is the same thing as a square root. So m is the square root of 64, which means m is 8. Let's look at 5. Log base 4 of m equals -2. Well, that can be rewritten as an exponential. The base is 4 of the logarithm, so the base of the exponential will be 4. 4. And then we jump across the equal sign. The power is -2, and the answer is m. So color coding like we've been doing. 4 to the -2 equals m. Well, what does a negative exponent do? Well, a negative exponent flips the position of whatever it operates on, right? So if I want to write this as 4 to a +2, I have to put 1 on top. So 1 over 4 squared equals m. So that means m is 1 over 16. So let's look at this just for a moment. Something interesting to point out. Log base 4 of 1 over 16 equals -2. Just plugging in the m into the place it was. 4 to the -2 is 1 over 16. So I said earlier that a logarithm, the result of a logarithm is a power, right? So if I have a negative power, doesn't that change an integer into a rational number? So anytime you have one of either your base or the operand of your logarithm, one is an integer and the other is a rational number, the power is going to be negative. Okay. So, oh look, here we have another one. Log base 5 of 1 over 25. So here is an integer for the base, and the operand is a fraction, a rational number. So the m is going to be negative. So let's rewrite this as an exponential function. The base is the same. The base is 5. And the power of my exponential will be m. And it equals the operand of that logarithm, which is 1 over 25. Well, 5 to what power is 25? 5 times 5 is 25, so 5 squared. But the problem is, this is an integer to a power, and this is a rational number. How do we get fraction? So it would be really helpful if we wrote this as 1 over 5 squared, right? But I can't put the 5 is not currently on the bottom. So the only way to make it that way is to change the m to a negative number. So I could write this as 5 to the -2. So m is -2. Let me rewrite with same process here. This is log base 5 of 1 over 25 equals -2. As I said before, if your base and your operand are different, one is an integer and one is a fraction, a rational number, your power will be a negative number. Let's try some more. Log base 11 of 1 equal m. We rewrite that as an exponential. 11 to the m equal 1. What power do we raise non-zero values to get 1? 0, right? Because any non-zero number to the 0 power is equal to 1. Okay, let's look at 8. We can rewrite this logarithm, log base m of 6 equal 1 as an exponential. The base is m, the power is 1, and the output is 6. Like this. So m to the 1 is 6, so that's just m, right? M is 6. Let's try another one. Look at 9. Log base 11 of m equal 1. You may be tempted to say that's the same thing as we did on 7, but I've switched the order of some things. So log base 11 of m equal 1 can be rewritten as an exponential. 11 to the 1 equal m. 11 to the 1 equal m. Well, that's just 11. Hopefully you're starting to get the hang of this. Let's do a few more. So log base m of 1/8 equals -3. Let's rewrite that as an exponential. The base is m, the power is -3, and the output is 1/8. Oh, look. We have a negative power, right? What did we have up here when we had a negative power? One of these was a fraction, one was an integer. So m is going to be just an integer. So m to the -3, if we want to write that as m to a positive power, we have to put the m on the bottom. So m to the -3 is the same as 1 over m to the 3. So notice they both have a 1 on top. And so that means the denominators have to be equal. M cubed equal 8. So what number do we cube to get 8? Well, we know 1 cubed is 1, but 2 cubed is 8. So m is 2. Let's look at this again. Log base 2 of 1/8 equals -3. Remember what I said earlier? If one of these is an integer and the other is a fraction, if you're looking at your base and your operand, your power will be negative. Let's look at 11. Log base 2 of 16 equal m can be rewritten as 2 to the m equals 16. So 2 to what power is 16? Well, 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. So m is 4. Last one. Log base 121 of m equals -1/2. So let's rewrite this. Base is 121. Power of my exponential is -1/2. And the output is m. So -1/2. Well, if I want to write the exponent as a positive, I flip the position of the 121 and I put it on the bottom. And then 1/2, remember, if 1/2 power is the same as the square root, this is 1 over like the square root of 121, which is 1 over 11. So m is 1 over 11. Let's confirm what we wrote earlier. Log base 121 of 1 over 11 equals -1/2. One is a fraction, one is a rational number, the power is negative. Okay? Hopefully you're starting to get the hang of this.